Hello everyone, my name is Jin Fan, and the name of the project is Create a Chatbot with Deep Learning and NLP. Here are a current problem. The natural language processing focus on the interactions between human and language and computers. It decides the intersection of computer science, artificial intelligence, and computational linguistics. NLP is a way for computers to analyze, understand, and derive meaning from human language in a smart and useful way. By utilizing NLP, developers can organize and structure knowledge to perform tasks such as automatic summarization, translation, names, entity recognition, relationship extraction, sentiment analysis, speech recognition, and topic segmentation. The development of NLP application is challenging because computers traditionally require humans to communicate to them via a programming language. Programming language are precise, ambiguous, and highly structured. Human speech, however, is not always precise. It is often ambiguous, and the linguistic structure can depend on many complex variables, including regional dialects and social context. The architecture of this project is using sequence to sequence. In this project, the inputs are flexible words and the output also is flexible. The construction of the sequence to sequence is different from the construction of the bag of words. The construction of sequence to sequence is a array restore the position of each word. So the length of the array should be about the same as the length of the numbers of words in the paragraph. The reason why the model can give the answer is that each word in the answer will pick up from the 20,000 elements with the highest possibility. LSTM model is also can be used in the output. The word is chosen as the one of the words of the answer should be also as the input of the LSTM. Chatbots that use deep learning are almost all using some variants of a sequence-to-sequence model. A sequence-to-sequence model is composed of two main components, an encoder NN and a decoder NN. The encoder's job is to encapsulate the information of the input text into a fixed representation. The decoder's is to take that representation and generate a variable length text that best responds to it. The types of deep neutral network is recurrent neural network. That's including bidirectional RN, deep RN, and LSTM network. The idea behind RNNs is to make use of sequential information. In a traditional neural network, all inputs are independent of each other, but for many tasks that results in a bad performance. If the network is in a sentence is going to be predicted, there is the need to know which words came before it. RNNs are called recurrent because they perform the same task for every element of a sequence, with the output being dependent on the previous computations. Another way to think about RNNs is that they have a memory which captures information about what has been calculated so far. Theoretically, RNNs can make use of information in arbitrary language sequence, but in practice they are limited to looking back only a few steps. The bidirectional RNN are based on the idea that the output at time may not only depend on the previous elements in the sequence, but also future elements. For example, to predict a missing word in a sequence, you want to look at both the left and the right context. Bidirectional RNNs are quite simple. They are just two RNNs stacked on top of each other, and the output is then computed based on the hidden states of RNNs. The deep RNNs are similar to bidirectional RNNs, only that we now have multiple layers per time step. In practice, this gives us higher learning capacities. LSTM networks use a different function to compute the hidden states. The memory in LSTM are called cells, and you can think of them as black boxes that think as input and the previous state and the current input. Internality that these cells decide what to keep in, and then they combine the previous state, the current memory, and the input. It turns out that these types of units are very efficient at capturing long-term dependency. The recursive neural network are also a general architecture to model the distributed reputations of a phrase or sentence with its dependency tree. It can be regarded as a semantic modeling of text sequence and handle the input sequence of varying lengths into a fixed length vector. The parameters in RCN can be learned gently with some other NLP texts such as text classification. Each unit can model the complicated interactions of the head word and its children. Combined with a specific task, RNN can capture the most useful semantic and structure information by the convolution and the pooling layers. The dependency-based neural network, in order to capture long-distance dependency, a dependency-based convolution model is proposed. DCN consists of a convolutional layer built on the top of long short-term memory network. DCN takes slightly different forms depends on its input. For a single sentence, the LSTM network processes the sequence of word embeddings to capture long-distance dependency within the sentence. The hidden states of the LSTM are extracted to form the low-level representation, and a convolutional layer with variable size filters and max pooling operators follows to extract test-specific features for classification purposes. As for document modeling, DCNN first applies independent LSTM network to each sub-sentence. Then a second LSTM layer is added between the first LSTM layer and the convolutional layer to encode the dependency across different sentences. In this project, the hyperparameters that I chose are epochs equals 100. Batch size equals 64, NN size equals 512, num layers equals 3, encoding binding size equals 512. decoding embedding size equals 512, learning rate equals 0.01, learning rate decay equals 0.9, minimum learning rate equals 0.001, and keep probability equals 0.5. In order to improve the model, I reduced the learning rate to 0.001, the batch size to 32, and I also increased the RNN size, the encoding embedding size, and the decoding embedding size to 1024, decreased the early stopping stop to 100. This is the result of the project, and I will input the hi, and the chatbot tell me how is it going, and I also input good and how are you. The chatbot answer me that's great. In this project, I realized a simple chatbot with deep NLP, but there are still a lot of things to improve. The most interesting part in the project is to build the encoder and decoder. In human speech, it is not precise because it's often ambiguous and linguistic structure. So that will affect the performance of the chatbot. A sequence-to-sequence model have two parts, an encoder and a decoder. Both of parts are two different neural network models combined into big neural network. And in the future, I will still focus on the aspect of improve the encoder and the decoder performance. And the next thing is explain the coding of this project. In this project, I use about 600 films conversations as the input. The first part of this project is data pre-processing. In importing the data sets, there are two data sets. The first one is lines, and the second one is movie conversations. And the second thing is create a dictionary that match each lines and its ID. And next, creating a list of all of the conversations and getting separately the questions and the answers. And I also doing a first cleaning of the text, such as I will split this word to I am, his, split it to the he is, she is, and so on. And the next thing, I cleaning the questions. Clean questions will be shown on that way. Clean questions. Here are the results of the clean questions. And also the same way to clean the answers. And next, filtering out the questions and the answers that are too short or too long. If the length of the questions less or equal than 25, I will append to this question to the short questions. And also, if the answers length also less or equal than 25, I will put it in the short answers. The next is creating a dictionary that matches each word to its number of accuracy. Each word will map to the number that this word occurrence. So I will create a dictionary to match each word and the number of this word's occurrence. And the next thing is creating two dictionaries that map the question's words and the answer words to a unique integer. Each word will map to a unique integer. And I also adding the last tokens to these two dictionaries. The tokens include pi, EOS, OUT, and SOS. The pi is meaning space, and it means no. And EOS is the end of the sentence. SOS is the start of sentence. And start of sentence. And out is that the word is not be found in the dictionaries. So the next is creating the universe dictionary of the answers words to int dictionary, and adding the end of string token to the end of every answer. EOS is be added as the every answers at the end, and then translating all the questions and the answers into integers. Also replacing all the words that were filtered out by out. And next thing is sort questions and answers by the length of questions. So the result of part 1 is I can get sorted clean questions and sorted clean answers. Here is the sorted clean answers. This is a sentence, and each number in this array means a word in this sentence, and each integer are unique integers. And part 2 is building the sequence to sequence. First is creating placeholder for the input and the target, and the next is pre-processing the targets. So such as creating encoder INN, decoding the training site, and decoding the text site. And next creating the decoder RNN. Building the sequence-to-sequence model. This is the most important part in this one. And the part 3 is training the sequence-to-sequence model. First is setting the hyperparameters, and I have introduced these hyperparameters in the PPT. And the second is defining a session, loading the model inputs, setting the sequence length, and the next getting the shape of the input sensor, getting the training and the test predictions. Next one is the setting up the loss error, the optimizer and the gradient clipping. And next is padding the sequence with the PAD token. Because such as I will let all of the sentences have the same length. If I chose the max sequence length of this sentence, and use the max sequence length minus the length of this sentence, the current sentence length, and this length will be at PAD tokens. And the next is splitting the data into batches of questions and answers. Splitting the data into batches of questions and answers, and splitting the questions and answers into training and validation sets. In this part, the training validation, I will choose 15% of the all size, and the training size I will choose 85% of all the total size. Second one is training. And part 4 is testing the sequence, the model. First is loading the weights and running the session. And next, converting the questions from strings to lists of encoding integers, and setting up the chat. If I import goodbye, and that means let the chatbot know it should be break. So it's in here I write the break. So all of this is the coding of the chatbot. Thank you for your watching.